7279. The wing of a weight-shift aircraft twists so that the angle of attack A. From the center of the wing to the wing tip is variable and can be adjusted by the pilot in flight to optimize performance. B. Changes from a low angle of attack at the center of the wing to a high angle of attack at the tips. C. Changes from a high angle of attack at the center of the wing to a low angle of attack at the tips. The correct answer is C. The wing of a weight-shift aircraft twists so that the angle of attack changes from a high angle of attack at the center of the wing to a low angle of attack at the tips. This twist in the wing is known as wash-in. It is designed to optimize the aerodynamic performance of the wing during different phases of flight. At the center of the wing, where the angle of attack is higher, the wing generates more lift. This is beneficial for maintaining stability and control during slower flight or during maneuvers that require increased lift. Towards the wingtips, where the angle of attack is lower, the wing generates less lift. This helps to reduce drag and improve efficiency during higher speed flight or when cruising in straight and level flight. By having a twist in the wing, weight-shift aircraft can achieve a more balanced and efficient lift distribution along the span of the wing, contributing to improved overall performance and handling characteristics. Therefore, the correct answer is the angle of attack changes from a high angle of attack at the center of the wing to a low angle of attack at the tips. 7245. During flight, advancing thrust will A. Increase airspeed. B. Cause the aircraft to climb. C. Cause the aircraft to increase airspeed and climb. The correct answer is B. Advancing thrust refers to increasing the power output of the engines, which results in an increase in thrust force produced by the engines. When thrust is advanced during flight, it has the primary effect of causing the aircraft to climb. To understand why advancing thrust causes the aircraft to climb, we need to consider the four forces acting on an aircraft during flight: lift, weight, gravity, thrust, and drag. Thrust is the force generated by the engines that propels the aircraft forward. When the thrust is increased, the aircraft experiences a higher net force in the forward direction. This increased thrust allows the aircraft to overcome the drag force acting in the opposite direction, resulting in an acceleration. As the aircraft accelerates, the increased airflow over the wings generates more lift. Lift is the upward force that opposes the weight of the aircraft. With the increased lift, the aircraft's upward force becomes greater than its weight, causing the aircraft to climb. It's important to note that while advancing thrust primarily causes the aircraft to climb, it may also result in an increase in airspeed. The increased thrust allows the aircraft to overcome drag more effectively, which can lead to a higher speed. However, the specific change in airspeed will depend on various factors such as aircraft configuration, atmospheric conditions, and pilot inputs. In summary, advancing thrust during flight increases the net forward force on the aircraft, allowing it to overcome drag and accelerate. This increased speed leads to an increase in lift, causing the aircraft to climb. 7246. The torque effect of an engine that rotates clockwise in a powered parachute is counteracted by A. Increasing the length of the right and decreasing the length of the left riser cables. B. Decreasing the length of the left riser cables. C. Decreasing the length of right riser cables. The correct answer is C. The torque effect of an engine refers to the rotational force created by the engine's propeller, which tends to rotate the aircraft in the opposite direction. In the case of a clockwise rotating engine in a powered parachute, the torque effect would cause the aircraft to rotate in a counterclockwise direction. To counteract the torque effect and maintain proper control and stability, the length of the riser cables can be adjusted. The riser cables are connected to the wing and support the weight of the aircraft. By adjusting the length of the riser cables, the pilot can introduce an asymmetric lift distribution to counteract the rotational force. In the given options, decreasing the length of the right riser cables would effectively reduce the lift on the right side of the wing, while keeping the left riser cables unchanged. This asymmetric lift distribution helps counteract the torque effect by providing more lift on the side opposite to the direction of rotation. As a result, the aircraft remains balanced and maintains its desired heading. 7247. The steering bars A. Are used during taxi operations with the parachute stowed. B. Control the outboard trailing edge of the parachute. C. Control the main landing gear brakes. The correct answer is B. The statement is incorrect. The steering bars in a powered parachute do not control the outboard trailing edge of the parachute. The correct answer is not provided in the options. In a powered parachute, the steering bars are used to control the direction of flight. The steering bars are typically connected to the rear risers of the parachute wing. By pulling or pushing on the steering bars, the pilot can deform the rear edge of the parachute wing, which in turn affects the flight direction and provides steering control. The steering bars are used during various phases of flight, including taxi operations with the parachute stowed. When the parachute is stowed, the steering bars are used to control the ground steering of the powered parachute. The pilot can turn the aircraft left or right by applying differential pressure on the steering bars, causing the aircraft to pivot around its main landing gear. Therefore, the correct statement would be: the steering bars are used during taxi operations with the parachute stowed. 7264. The center of gravity tube is A. Lengthened for heavier pilots. B. Shortened for lighter pilots. C. Lengthened for lighter pilots. The correct answer is C. The center of gravity tube in a weight shift control aircraft is lengthened for lighter pilots, not shorter pilots. The center of gravity, CG, tube is an adjustable component in the aircraft's control system that allows the pilot to change the position of the CG. By adjusting the length of the CG tube, the pilot can shift the CG forward or backward to achieve the desired balance and stability of the aircraft. In the case of lighter pilots, who have less weight, the CG tube needs to be lengthened to move the CG forward and maintain the proper balance of the aircraft. Lengthening the CG tube shifts the location of the pilot's seating position forward, which helps achieve the desired CG position. Therefore, the correct statement is: the center of gravity tube is lengthened for lighter pilots.